Okay, cool. Let's get started. Hey everyone, I'm Nikhil. This is ORI 5355 or Info 5370, I believe. People, data, and systems. So let's see, the clicker does not work yet. Let's see. Okay, now it does. Okay, so today is going to be kind of a chill day. Mostly just give an overview for the course, talk about the syllabus, talk about the various topics, and then with like some time permitting, I'll just dive into the first lecture. But like odds are, we're not going to not going to get too far on that, if at all. And then we'll end also a few minutes early if anyone has like specific questions about like enrolling or getting off the wait list and things like that. But this sort of goes for the entire semester, but especially sort of today is please interrupt at any time with questions, but like raise your hand and don't just like yell at me. Okay, so who am I? I'm Nikhil. I'm a new assistant professor here in as part of ORIE. For those of you who are still also figuring out Cornell Tech, that's Operations Research and Information Engineering. My research is broadly in like the applications of a lot of the things that we're going to talk about: algorithms, data science, mechanism design, to the study of societal systems at large. And what I bring to the course is, besides of course like the academic research experience, I have a lot of practical experience working at marketplaces like Uber and Upwork. I also spent most of last year at a data science firm helping progressives win elections, so sort of bringing a lot of practical experience there to the course. The TA is Jia Liu. He's a PhD student based in Cornell Ithaca, also in ORI. Because he's in Ithaca, you can here see his face. He's not going to be here with us in class for at least most of the semester. So his office hours are going to be remote. And his research is also on the application of machine learning and data science to marketplaces and other things, and especially looking at strategic data sources. So somewhat what we're going to talk about this semester. Okay. Any questions so far? Everyone good? You can hear me? Okay. This is going to be a lot more fun if people ask questions and interrupt me as much as possible. Okay. So what is this? So what are we going to discuss today? First, I'll give you a very brief what this class is not about, and then we'll jump into what this class is about. So first of all, this is not an intro to data science course. Hopefully, y'all have either taken one or are in the process of taking one right now. So something like urban data here at Cornell Tech would work. This is also not a course that's going to teach you how to train 20 different kind of cool prediction models. We're not going to cover deep learning here. We're not going to like cover 10 Python packages for like how to train like different kinds of prediction models like clustering or whatever. If you want something like that, hopefully you've taken or are in the process of taking applied machine learning. And sort of if you haven't taken either of those courses or the equivalent, hopefully you're in one of them, because like sort of simultaneously those classes will cover a lot of like Python basics like pandas or like using Jupyter notebooks or things like that that I'm going to somewhat assume that y'all know in this course. Like maybe in TA office hours we're going to cover how to use some of those, but for the most part I'm going to assume that you know how to use those or can pick them up on your own. This is also not a deep learning course. There's a bunch of other courses here at Cornell Tech, especially in the spring, that'll teach you that. This is also not a course about how to scale data science up. So how to work with terabyte-sized data sets or use SQL and like all of that fun stuff. That's very important, but I would take data science in the wild in the spring. And then finally, there's going to be a little bit of math, but this is also not a course that's like a theoretical analysis of online marketplaces like pricing and queuing and things like that. There's a class called Service Systems and Online Marketplaces that's usually taught in the spring. I would take that if you want like a deep dive on the like sort of like the more theoretical aspects of these things. I will be talking about how to apply things that you might learn in a class like that into practice. But I don't like sort of by no means do you have to have taken a class like that for this class. Are there any questions about what this class is not about? Okay. So that's a lot of things it's not about. What is this class about? So I'm going to assume that you either know or you're in the process of learning the machinery for how to train prediction models. And then this class is about how do you make algorithmic decisions using those prediction models. So like, you can make a prediction for, what the weather is going to be tomorrow or how many customers are going to show up tomorrow or whatever. How do you actually use that in a real world setting? So in the real world, there's going to be a lot of things that you don't cover in those classes. So you have things like user incentive. So your model is going to change the behavior of the users because, like they care about not having high prices. So they're going to have strategic behavior. Their behavior is going to be adversarial. You're going to have a lot of real world constraints that these classes often don't get to. So you have censoring of certain kinds or selection effects. You're often, in most of the applications that we're going to talk about in this class, in a far smaller data regime than can work in, for deep learning or something. But even in, it's not just like the amount of data, but also the kind of data. So in a lot of prediction models, when we're talking about personalized pricing or personalized recommendations, you actually don't have any historical data on the actual person that you want to do anything about. And so how do you sort of make some progress in those settings? In the real world, there's a lot of constraints caused by either perceived or real fairness or business constraints, or like fairness and ethical constraints. Like for some reason, people sort of often don't like experimentation, even if, for example, they individually like all the things that you might have experimented sort of them on, but just like the fact that there's some randomization means that people don't like it. There's a lot of things like that in the real world that you have to either communicate around or work around. In the real world, you have business and resource constraints. So even if you think that everyone in the world is going to like this like table that you're selling, if you only have 10 tables, that should affect the price at which you sell things at, right? Just like predicting who likes what is not enough to know what am I going to do with that prediction. There's competition. So your models are not just in this world by themselves. They're being deployed in a world where there's 100 other companies or other agencies or whatever doing similar things. And so hopefully that should affect how you think about at what price you want to sell things, what you recommend to people, or like what you ask people to do, or so on. And the real world is dynamic. So you can't just train a model once, sort of deploy it and declare victory and move on to your next project. You have to think about maintaining it. You have to sort of think about changing data and distribution shifts. And so how do you sort of measure things or deploy models in those real world circumstances? Okay, so any questions so far? Cool. Okay, so who is this course for? Like I said, either you already know or are in the process of learning the machinery of how to train and evaluate prediction models. So, something as simple as regression in Python, if you know how to do that in a few weeks, I think Urban Data will have taught that by like 3 weeks from now. You should mostly be good. But, even if you sort of maybe know a lot more than that, you've been here a year and taken a lot of other courses, sort of because I'm not teaching that machinery, I think the course will be interesting to you and will be accessible at either level. And then you want to actually learn how to use these models in places like online marketplaces, so like Uber, or Upwork, or Etsy, or Netflix, or the 1,000 other marketplaces that y'all probably interact with on a daily basis now. Or in government, so things like you're running a transportation system, you are at a place that does polling, or you're at the census, or you're just providing services in general. New York has been trying to implement congestion pricing for 10 years now. So, maybe you graduate and you're the next data scientist or person working on congestion pricing there. And in general, just any data science setting about people. Okay. So at a high level, what is the organization of this course? So we're going to have about 2 to 3 weeks. This is going to be like mostly somewhat orthogonal to the rest of the course, but it's going to be just about what is data, how to collect it, and like common challenges in collecting data. This is simultaneously orthogonal to the rest of the course in that you're not going to be training prediction models for anything in this module, but it's also central because like any model that you work with is going to have the data challenges that we discuss here. So the reason it's designed this way is hopefully 2 to 3 weeks will be enough for example, applied machine learning and urban data to teach you some of like the intro machinery. Okay. And then after that, we'll get into, I guess, like I think everything is the meat of the course, but one of the meats of the course, I'm vegetarian, so maybe that's a bad metaphor. Okay. On analysis. So we're going to sort of split this up into 2 areas is like, what are common tasks that you might need to do in people-centric systems? So the first one is going to be recommendations. So you have your Netflix, you have a catalog of 1 million items or 1 billion items or whatever they have now. What 20 items do you show people on the home screen? And how do you personalize that? Or maybe you just have 5 items, and which one item do you show people or match people with? And then pricing. So at what price do you sell goods? Do you make that individualized, or do you just have a general posted price for everyone? And then experimentation. So how do we know that your model is good in a real world setting? Oftentimes cross-validation loss in a training set is not really going to get you anywhere. Or when you deploy it, you're going to have all of those like real world circumstances I talked about earlier. So how can you tell that your model is any good? And then a bunch of like a grab bag of miscellaneous topics that we'll figure out later based on interest. Okay, so I'm gonna dive into a little bit more detail in each of these things, just because we have some time. So the first part of the course is, again, I think we're going to start off with like, what is data? Like, I think the first question I'm going to ask you all next week is literally try to define data to me. But what is it? Where does it come from? What does it represent? What are the challenges when we're collecting it? So common challenges include selection biases of all kinds, censoring. So, you can't see, if your company is only a year old, you can't actually see how people behave a year and a half with your prices, right? So you have censoring of certain kinds, or especially if your company is growing, you probably can't even use the data from 3 months ago. So how does that affect like the pricing that you might do, or like how might that affect all sorts of things down the line? And other challenges. We're going to have quite a bit of an extended example using polling and survey methodology, and this is for 2 reasons. First, I just find it very interesting, but 2, or I guess a few reasons. So first, I just find polling and surveying very interesting. 2, again, this will allow hopefully those of you in applied machine learning and urban data to like pick up like maybe more core prediction tools while we're doing something else in this class. And then 3, I think it's just a great case study for like what are the types of challenges that you actually do see in data collection or using real world data, even in other models, but it's sometimes simpler to see those challenges in a polling setting. And so we're going to cover what goes wrong in measuring opinions. So you just want to estimate the mean opinion of something in the population. How do you go about doing that? What goes wrong? We're going to talk about some techniques that somewhat work. No polling technique. For those of you who know a bit about polling for the US federal elections, you know that these things aren't perfect. You know that there's a lot of real world challenges. We're going to talk about those. We're going to try to talk about some of the techniques that pollsters use. And then we're going to quite extensively use in both in the homework and in class, the US 2016 polls as a case study. And then we're going to end this module with sort of going away from polling and surveying to how do these same challenges show up in other contexts that you might care about. So online ratings, recommendations, how do you do privacy when collecting data, and so on. And then something I'm really excited about is we're going to have a guest lecture from, for those of you who know what 538 is, I guess for those of you who don't, it's sort of one of the premier data journalism websites. They do a lot of predictions for elections, but more like they've just expanded now to data journalism in general. I have a friend actually from high school. He used to be a longtime data journalist there, and he's now a professor at Columbia. And so he's going to give a guest lecture on sort of, one behind the scenes. So he was there both during the 2016 and the 2020 elections. So he'll talk about behind the scenes on like polling and their data infrastructure there. And then, any questions y'all might have. Any questions about that? Somebody has to ask a question at some point. Oh, great question. So, okay. So I'm going to be, if I don't do it, remind me to repeat the question, because the way this room is set up is it doesn't pick up any audio from y'all. It just picks up audio from me from the mic. And so in the recordings, we're going to need me to repeat the question. So please remind me if I don't.
Hi, Nicole. Nicole? Sorry to interrupt. We seem to have lost connection to your mic on Zoom. Could you check that?
Can you hear me now?
Yeah, very clearly.
Okay, what was the last thing you heard?
When you said you wanted to repeat the question.
Oh, okay. Okay. I will give a very short summary of what I just said. Okay. So, I asked y'all to bear with me a little bit where we're going to be recording the courses the entire semester, posting. I'll talk about recordings and logistics and all of that later, but especially this is important for the first few weeks of the semester because some people are still abroad and can't be here in person yet. So ask you to bear with me. Okay, so the question, so I'm going to repeat the question. So the question was, where does mechanism design come into play in the topics that I'm going to discuss in this course and that I've shown so far? Okay, so for those of you who don't know, mechanism design is a form of applied game theory that sort of tries to think about, if I set the rules of the game in a certain way, using the word game very loosely, if I set the rules of the game a certain way, what are the outcomes going to be? So, for example, you might think in an auction setting, if I make the so it turns out there's a rich history in this field of how to design the right type of auction. So let's say you're selling one item and a bunch of people submit bids. What price does the highest bidder pay? So okay, you're gonna give the item to the highest bidder. Do they pay the price that they bid, or do they pay, for example, the second highest bid? It turns out the second highest bid is what's done in practice in most places and is like quote unquote the right thing to do because it has a property called strategy proofness, in that if that's the bid that people pay, people don't want to lie about how much they value the item. If they value the item at $10, they're going to bid exactly $10. And you can walk through the math on why that's the right thing to do. Okay, so that's mechanism design in a nutshell. What I mentioned earlier and sort of what will come to play in this course is a lot of my work is on what's called market design, which is you integrate all sorts of markets or real world settings have mechanisms inside them. So in ride hailing, you have to set a price you're going to charge each rider. You have to set a price for the same trip that you're going to pay the driver. There's all sorts of decisions like, do you pay the driver a fixed proportion of that trip, or do you pay them something else? And something like, so to keep the pricing context, in something like Airbnb, do you Airbnb doesn't get to control the prices that all the hosts set, but rather they're going to do recommendations. How can Airbnb recommend that this host set a price at something when the host knows that Airbnb is also recommending a price to everyone else? So is the host going to be like, Airbnb is recommending I set this at $100, but really they're trying to screw me over so my neighbor gets the rental instead because Airbnb wants to make my neighbor happy for some reason. So mechanism in market design is all about sort of these sorts of questions, which is how do you sort of set the rules of how you're going to deploy these models or use these models when you have to take into account strategic reactions. And this is usually done in a theoretical manner. So if you read research papers in this, it's all just going to be a bunch of algebra and math, as opposed to usually working with data. In this class, we're going to try to sort of use the more applied side of this field, which is, your machine learning model in some sense is a mechanism, right? It's going to spit out a price. That price has, so let's say you're spitting out a price every 10 seconds and you add noise to your price that goes up and down every 10 seconds. People are going to react to that by just waiting, 10 minutes to find the lowest price and then select something like that. So how do those sort of strategic reactions come into play in a machine learning or data science setting? Did that very long-winded answer to your question? Okay, great. I tend to have long-winded answers to questions. So if you want to filibuster the class and have me not get to something, ask me questions. Any other questions?
Could you back into the mechanism from observing the outcomes, or is that a valuable thing to do?
Yeah, so that's a great question. So okay, so the question was, can you back into the mechanism by observing outcomes? And so I would say there's maybe a few parts to that question. So the first part is can you figure out what mechanism someone else was running by just having a bunch of observations? And is that a valuable thing to do? So definitely that's yes, in that, so for example, there's a lot of audit studies done, or not a lot, there's a few, these are hard things to run, but you can have things like audit studies on like, people external to Uber will observe a bunch of prices because, they'll like plug into the API or something. And then they'll try to back out what are prices a function of. So certainly a valuable thing to do in audit studies. There's another like side of this field that's emerging, which is, can you like, if you have a bunch of data or like you can simulate a bunch of marketplaces, can you like find the quote unquote optimal mechanism for something? And turns out there's like this really interesting line of work that uses like reinforcement learning to do exactly this. So they'll simulate it like an entire economy and then try to back out what is quote unquote the optimal like taxation policy for this economy. Any other questions? Yeah, so if you're interested in this kind of stuff, there's definitely a few other OR classes, I think, at Cornell Tech that like really dive into like mechanism design. In this class, we're only going to sort of touch on it in the sense that like a lot of the lessons from there are going to come into play and like what are the implications of your model or the implications of what you're doing like with a data science model or machine learning model. Okay, cool. Any other questions? Okay, so the next part of the course is sort of recommendation systems. And so it's, you have a bunch of items, which ones do you recommend to people? And some of you may have done this in some other classes, I'm actually not sure, but we're gonna start with like an entire lecture on just the basics of recommendation systems. So, these words probably don't mean anything to you at the moment, but things like collaborative filtering or matrix factorization, which basically everyone uses right now, like Netflix and so on, which is how do you, I have two people and they have quote unquote similar item ratings in the past or view histories in the past. How do I use that to recommend each of them items based on, for example, what the other person has seen? Okay, and then we're going to get into so most of the recommendation stuff that we're going to cover is always going to start out being personalized, right? Like everything's based on personal view history. But then we're going to get into individual versus demographic based view history. So in a lot of times, and especially if you're all at startups, you're going to be having what's called the cold start problem, right? So if someone just signs up to your service today, you have no history on them. You like maybe know, from their cookies or whatever, you can grab their demographic data. You can grab like a limited set of data about them, but you like don't have any like, actions that they've done on your website yet. How do you do recommendations then, and what is the cost, right? Like, can you like, what is, how does that compare to like the ideal thing that you might want to do? In the real world, there's a lot of other challenges. So maybe not at Netflix, but if you're Amazon, you have capacity constraints, right? So you only have 10 of an item. You can't just recommend that same item to everyone, because what if 100 people choose to buy that item? So how do you do sort of optimization across your entire portfolio of items based on capacity constraints? A big recent thing in the research literature, but also in practice, is what's called two-sided fairness. Or so in general, when I use the word two-sided, I'm often going to think about two-sided marketplaces where you have consumers, often such as yourselves, on one side, but then you have producers on the other, right? Like there are people, like there's Amazon sellers. Like not everything on Amazon is like made by Amazon, right? There's like individual sellers, or not everything on Netflix is made by Netflix, Spotify, and so on. And so often you can, especially in labor markets like Upwork or TaskRabbit or whatever, right? There's like real people on the other side, and like you should care about those people. And so like, how does a recommendation system take into account optimally not just what the user wants, but also what the other side wants? Okay, and then maybe like connecting it to the first module, like how does, in these recommendation systems, one of the core features which makes running these in practice quite hard is that you have a big data censoring problem. In that, for example, people only rate things that they've seen, but you only rate places on Airbnb that you've been to, but you chose to go to that place because you thought you would like it. So how does that affect recommendations you would give like a completely new person? Or that also induces feedback loops, right? So people are recommended some items, and then they have an experience, but then prior recommendations now affect what data the future recommender system uses. So how do you deal with things like that? Also excited, we're gonna have a guest lecture from Amy. She's a PhD student here who has a lot of research and practical experience, I think at Wayfair and a few other places, building recommendation systems. Okay, and then we're gonna get into analysis, which is at what price should I sell my items? Here, unlike recommendations, we're gonna start out with non-personalized pricing. So this is like something that you might cover or might have seen in an operations course for those of you who've taken one, which is just optimal pricing given market data. So I need to set one price for the entire market. I have some limited data on like at what prices people have either bought something or expressed that they would buy something in the past. What do I do? And then we'll get into individual and demographic based pricing. So again, personalize that, and how do you go about doing that? Dynamic pricing, so pricing over time. And so a feature of a lot of these online marketplaces is that market conditions change quite a bit. A ride-hailing marketplace probably needs different prices in Manhattan at 6 p.m. than it does at like 2 a.m. in the suburbs. So how do you do dynamic pricing over space and time? And again, this is where some of the mechanism design ideas come into play, in that, if you have like very different prices from here and like 100 feet away, I'm just going to walk 100 feet away if I observe that. Something I'm really excited about, I think it's going to be one of the most fun classes here, is we're going to have an exercise on when y'all think personalized and dynamic pricing is the right thing to do. So for example, I think most of you hopefully would say, there's a hurricane coming in Louisiana right now, hit last night. I think most of you would say that would be a bad idea to price gouge like bottled water the day before a hurricane. Some of you may or may not say that it's a bad idea, or like it's unethical to raise prices on umbrellas when it's raining. But whether or not you explicitly know that, your dynamic algorithmic pricing is like learning all of those things and is doing all of those things. So if you're not careful, on Amazon, you set up an algorithm to price your thing, you probably are going to price gouge people, and you probably hopefully don't want to do that. So we'll explore some of your intuitions on when this is okay and when it's not. And then, we'll use online marketplaces and like transportation concession pricing as case studies here. And a guest lecture is TBA. We haven't figured out exactly who it's going to be, but hopefully someone. Okay. Finally, we're going to talk about experimentation. So, or not finally, second to last topic, experimentation, which is how do I know that my treatment, my product, my deployment, whatever it is, how do I know that it's working? Again, here, we're going to start out with something that some of you may have covered in other classes, which is half a lecture on the basics of A/B testing. So, or basics of clinical trials, which is simple idea. You have two things. You have a vaccine and you have a placebo. You give them each to 5,000 people, and then you just observe them in the wild and see, which people get sick and which people don't. So that's like the ideal, that like we would all like that just works all the time. Unfortunately, in essentially any people-centric system, so any online marketplace, any two-sided marketplace, certainly experimentation on Facebook or like any network-driven company, like that's just not going to work for a variety of reasons, but most particular, it's not going to work because of interference of some kinds, which is that people are no longer independent. So if I give, one person, I mean, this is somewhat true for a vaccine as well, right? If I give everyone in the town the vaccine except 10 people, then those 10 people are somewhat going to be protected because of herd immunity. And so even though they didn't get the vaccine, they were protected because of other people. That's interference across units. And that's the norm in any experimentation in any real world setting, and like that we're going to talk about in this class. So experiment, like the standard technique is going to fail. And so then we're going to talk about how do you deal with that. And similarly, a particularly pernicious form of interference in online settings is interference over time. And so let's say, again, you're a retailer and you sell all your, you're experimenting over time. And I say, for this week, I'm going to make all my prices at like 90% off. Then like everyone's going to buy something this week, and then there's going to be no one left to want your item who's going to buy it next week. And so that's interference across time. Similarly, there's special kinds of interference in two-sided marketplaces. And that now, if you're experimenting just on the consumer side, that's going to do funny things to the producer side. Or like roadways, right? So if you're experimenting just on users, it's going to like do something to the roads, and so that's going to cause interference. And then finally, in most of these settings, you're not just running one experiment. You're rather deciding between running which 1,000 of 10,000 experiments you want to run today, and how do you make trade-offs of experiments across each other. And we're going to talk about this in the context of somewhat COVID and clinical trials, but mostly in online marketplaces and in more like tech settings. Okay. And then finally, the last few weeks is going to be a bunch of, I'll probably send out a survey in the middle or near the end of the class on which topics that we want to cover. But some of the options is some of you might have heard of something called differential privacy. It's making a lot of news right now because the US Census just adopted it. But differential privacy is all about how do I share or collect personal data in what's called an optimally private manner. So how do I share data such that even though I shared my data, no one can, and people saw the entire distribution of answers, no one can use that to back out what I said. And it turns out in a lot of settings that's actually easy to do, and differential privacy is all about how to make that not easy to do or impossible to do. We might do a deeper dive into fairness audits. So how do you measure whether your algorithm is quote unquote unfair, whatever that means. Might have a module on algorithmic explainability or transparency. So in a lot of people-centric settings, especially if you're in government or running an agency, but also in online marketplaces, increasingly people want to know why you did something. Why is this person eligible for a loan and that person isn't? Why did I get this price and someone else got that price? And often, the models that you're going to learn in most of your classes are sort of initially black box, and that they don't readily give explanations. So we might talk a little bit about how do you generate explanations or communicate what you're doing. Similarly, in a lot of these marketplaces, there's something called human in the loop. So my favorite example of this is, how many of you are aware of Stitch Fix? Okay, so some of you. So Stitch Fix is an online clothing retailer that they send you, you sign up and then you pay a bunch of money, and then they send you every so often a box of 5 or 6 items, clothing items, and then you decide which ones you like, and you keep those and you pay for it, and then you return the ones that you don't like. And they're fantastic in that they're an algorithm data science first company. They have probably 10x the number of data scientists that you like think they should have, or that like any like reasonable competitor has. And what they essentially do is most of their pipeline is algorithmic. So they have, like, so what they have is they have stylists that get to see an algorithmic's recommendations for you. And then, maybe the algorithm will generate 100 items. And then the stylist that you actually have like talked to through like text or whatever will make the final decision on which like 5 items to send you. And so there's like special kinds of things you want to do when you have a human in the loop in your model, right? So it's not just the machine learning model making all the decisions. It's just not it's also just not a person. So like, what do you do differently in those settings? Also really excited, we have a confirmed guest lecture from Lily Zhu. She's a PhD student at Harvard who applies data science and game theory to anti-poaching efforts. So this is another example of like applied mechanism design where you don't, or applied game theory, I would say more naturally, is if you set up like a trap in just like the same 10 locations every day, then like eventually poachers are going to realize where those locations are, and they're no longer going to like be there, right? They're going to be somewhere else. And so how do you use like a combination of like data science and surveillance techniques to decide where to like, monitor every day? And she does a lot of things in practice, actually. Okay, so any questions on that? Just curious, considering your experience, can you or will you touch on kind of like tools or like SAS tools, non-SAS tools that actually help look at experimentation that's running, things like weights and biases or other kind of? That's a good question. So I'll get to it in a little bit, but so the homeworks will have like a quite substantial programming component every homework. So there's going to be like a homework on experimentation. And so like I won't like deep dive into any particular tool in class, but in the homeworks often you'll use like some like Python package that like you might use in industry, or like similar to the one that you might use in industry, or because the course is more conceptual, we might like, for example, ask you to like hand program certain things just so you understand the concept, and then like there'll be like the end of the homework will like ask you to potentially and like use one of those tools. Sorry, y'all didn't do your job, which is asking me to repeat the question. Minus 10 points to everyone. I don't know what those points are, but so please remind me to repeat the question. In this case, the question was, am I going to cover a lot of industry tools that you might use, for example, for experimentation or so on? And I think long-winded answer, but I think the short answer is no. The long answer is maybe. The longer answer is yes. Okay. So I covered a lot of materials. Let me just, I do want to spend, we have what, 30? When does this class end? 9:55? Sorry, 10:55? Okay. So we have about 30 minutes left. I'm going to quickly go into the class themes, and then we'll, do the fun syllabus stuff. Okay, so hopefully y'all are getting a sense of like the things I care about and the things this class is going to cover. But here, let me just like, summarize what I hope you'll take out of this class. So oftentimes the like modeling sophistication is not what matters. So like, okay, I want you to take applied machine learning, but you're going to learn 100 different kinds of prediction models, how to do there. Oftentimes it like doesn't matter which one that you use. Like even like a simple regression model is going to outperform the fanciest model if the regression model comes with the right data and the right interpretation, and like the right domain application. And so like sort of related to that is like the thing plaguing your system, the solution is often not to go fancier and to like run some algorithm to fix it. You're not done after you train a model. You also shouldn't start there. There's like 99% of the work is outside of training that model. And most mistakes are made and just like, and I think this is why sort of the answer to the question that I did was, like the course is mostly going to be about, especially even in the homeworks where you're programming, is going to be more of like, applying the concepts, the basic concepts, as opposed to specific Python packages, and that most mistakes are not made in like you use the Python package incorrectly. Most mistakes in statistics and data science, even by experts, are made by you just like misunderstood or misapplied the very basics in your setting. You just have to become a domain expert in whatever you care about. Like this is oftentimes machine learning or data science is accused of being like sort of like a parachuting expert that like pretends that they know everything. Just like in non-data science settings that rarely works, it doesn't work in data science settings either. You have to design with privacy ethics and fairness or transparency in mind, because it's not something that you can just add on at the end. And so hopefully, for example, the pricing exercise that we do will drive this in. Is that like, you can't just like install a package and at the last minute, like make your model fair. Historical performance on training set, I think a lot of these themes are repeated, but historical performance on a training set is almost never the right measure for what you care about. And again, concepts and not just methods. But then lastly, which is you should always sort of like the most successful person in industry is often the person who's just slightly more curious than anyone else about like what's going on in their data set. Like often it's like someone who spends just like a little bit more time or a little bit more effort or whatever, or the right amount of time on the data and just like figuring out what is like the one like concept or idea or whatever, like that's plaguing like all of the data. And that's off like, just like data exploration and figuring that out is often more important than like spending that time training the model. Okay, any questions about the content? Otherwise, remaining 20 minutes or so on like boring syllabus stuff. No? Okay. No. Yeah, so I think, so it was taught last year. I'm not sure if it's going to be taught this year. It's called Service Systems and Online Marketplaces. It's in Ori. Yeah, oh, sorry, let me repeat the question. So the beginning, I said, this class is not one of 4 or 5 other classes. And one of the ones I said was this is, for the most part, we're not going to do like a full theory analysis on like the right kind of pricing or whatever, like a pricing or queuing or whatever that you might have in online marketplaces. And so, yes, that course was service systems and online marketplaces. And yes, they are more theoretical. So like there you might like do proofs or like derive the optimal price and like in homework show why that it is and so on. We're going to do very little of that in this class, maybe a little bit in homeworks, but like not too much. Someone else raise their hand?
I was just going to say you didn't repeat your question.
Oh, okay, thank you. Just like, that's the one exception to interrupting me without raising your hand. Just like scream it out. Huh, no one screamed out that time what that person said. Okay, sorry. Okay, so moving on to boring syllabus stuff. Okay, so I typically don't like when professors read out the syllabus to me, but I'm going to do it. Hopefully this will be fairly quick, and I'll just do the highlights of what to sort of take into account. So about 70% of the class is going to be homeworks and a project. 30% is roughly what I'm going to call participation / like attention checks, which is show up to class, ask questions, talk, participate in a discussion, sort of just like be a community member of the class. And then I say biweekly, but I don't know how many there's going to be. Probably not actually going to be biweekly. There's going to be quizzes, usually after the homeworks are due, which is like, should be fairly straightforward if you did the homeworks. Yeah, so you'll see it in the syllabus, but homeworks you can do with other people. I mean, like you can talk to other people about it. You have to write up your own solution, but homework you can do, I believe, I'll have to recheck. Homework you can do with other people. And the final project you're going to be, or like you can talk to other people in the homework. You have to do it alone. In the final project, you'll do it with a partner, hopefully. You can also do it alone if you want. The quizzes are going to be completely alone.
If you collaborate on the homework project, you mentioned the other person.
Yes. Yeah. So the question is, do I have to like, do you have to like write down who you worked with? So yeah. So like in the homeworks, like we're gonna ask you to just like write down who you talked to about the homework. You have to like write up your own solutions. On the project, if you're in a team, you have to like sort of you're gonna submit one thing with your partner. Any other questions? Okay. There's a late day policy in the syllabus. Note it down. I'm not going to repeat it here. Okay. So I personally think the project is going to be one of the most fun or the most fun part of the class. It's really going to be a chance to apply everything, like all the concepts that we learned throughout the rest of the semester. And so you're going to take the role of one entity in an online marketplace that you have to sell goods. And you're going to be competing against the other project groups in the class. And so it's basically an algorithmic pricing and recommendation thing with competition. So you're going to use prediction, pricing, recommendations with capacity constraints, experimentation, and so on. I think online we've already posted like a slightly more detailed description, but sort of the TLDR is you're gonna write some code, and then there's gonna be like, let's say in a given competition, there's gonna be one other team, and then 1,000 customers are gonna show up sequentially. You have to sort of post a price at which you're gonna sell an item. So think that you're Uber and Lyft, and a customer wants a ride from A to B, and like the other team is Lyft and you're Uber. And so the customer is obviously only going to purchase a ride from one of you, and you have to like set pricing to do that. Haven't figured out what the winner's prize is going to be. Maybe cash, maybe you don't have to write the final report, maybe an A+, I don't know. We'll figure that out. Any questions?
Question on the competition, is the winner going to be whoever makes the most money out of it, or whoever like gets all the buyers? Because I could imagine someone like saying 1 cent for all the rides.
Yes, great. Yep, great question. So the question is the winner in the competition, like what's the metric in the competition? Is it profit? Is it revenue? Is it the person who sells the most? Because if it's the person who sells the most, then you would just like price everything at 1 cent and call it a day. It's going to be profit, or in this case, equivalent to revenue, because we're going to fix the costs.
Yeah, I was thinking about the target as well. Is it like a continuous thing with multiple iterations, or is it just one round?
Yeah, so I'm in the so it turns out this is like annoying to actually write the code for this using OpenAI Lab, or for those of you who don't know, or for those of you who know that is. But yeah, so so the question was, is it is it just one round? One buyer comes in for 2 people, or is it like 1,000 buyers come in? What I'm imagining, and like the current code iteration at least will have, is you're going to go like head to head in like either a tournament or a round robin or something, and each head to head with like 2 teams is going to have like 1,000 rounds or something. But the rounds are going to be connected because you're going to have capacity constraints, right? So like you're only going to have 100 of the item to sell across 10,000 rounds or 1,000 rounds or something. And so they're connected in that sense. Any other questions? And I think this came up earlier, so I'll point out is like, I don't want you to like worry if you like didn't come into this class with a whole lot of programming experience. I think for 2 reasons. The first is, I think what I said like earlier about the class themes is actually true. It's not something I just said. It's I do not think the person with the most machine learning experience is going to win. I don't know how to measure that. I don't know how to put money on that, put bet on it. But like, I would bet if there was a way to do it, that the person with the most Python or machine learning experience is not going to win. The second thing is your grade in the class or even in the project is not like really like very much going to be determined by your performance like in the actual competition. There's like other parts of the project that your grade will be based on.
Yeah, I have one question. In the syllabus, it sounded like this is sort of like a continually evolving project over the course of the semester. Is that, how should we think about the different checkpoints
Yeah.
along the way, or is there just sort of like, you know, one sort of just come this head-to-head you're talking about? Does everything lead up to that one head-to-head, or are there multiple along the way?
Okay, great question. So the question is in the syllabus, there's like multiple parts to the project. How should you think about that? The answer is it's sort of there are multiple checkpoints that are all going to lead to sort of like, there's going to be one day where like, you know, we'll have it in class, we'll have a competition day, I'll build like a nice UI. So like, we'll have some fun, maybe bring some pizza or something. And so that's what like the project is going to build up to. But like, you know, earlier, we're going to ask you to turn in a few other things for just so like as like good checkpoints that like you have like good recommendation or pricing down and so on. And then there's going to be a report due after the competition, which will be like the report will be due during finals week. Any other questions? Great question. So not officially in any way. Oh, yes, great, thank you. So the question is, how am I measuring participation? The answer is like, I'm not like taking attendance or anything along those lines. I'm decent with faces, so like I will roughly know. I'm terrible with names, but that's what the class roster is for. But I'm like decent with faces, so like, you know, I'll roughly know who shows up and who doesn't. The quizzes are going to be in class, and so if you happen to miss like the quiz day, then like, you know, luckily one of the quizzes is dropped. So, but that's going to be in class. The guest lectures, I'm going to sort of ask to sort of, especially in guest lectures, I'm going to care about attendance. We might do like exercises in the guest lectures where like attendance is going to matter. And then participation in like sort of in the online like question and like in ed discussion. That's like like, yeah, that was a very wishy-washy answer. But it's not like, I'm not taking attendance like every day. Okay, yeah, so please don't come to class if you're sick. As much as possible, I'm going to try to make the semester like about flexibility. So what that means is, you know, class recordings are going to be available online. This is being recorded through Zoom, and you know, they'll just be available for everyone. I'm not allowing remote participation just because like in this auditorium, it's like a little awkward when like a voice comes from above, which sometimes the TA's voice will come from above, but you know, yeah, I'm not terribly comfortable in this room to do hybrid participation, but the recordings will be available. That being said, with the exception of, you know, religious holidays, sickness, like life events, I do want you in class and participating. And so like sort of the rule of thumb is like, if you're going to miss more than like 20% of class, by miss, I mean like not be here in person, then like contact me and we'll work with student services and SDS to come up with a plan. Like, I don't want this to be like onerous in any kind. You know, I recognize all of you have lives and things that matter outside of this course. That being said, I hope this class is also an important part of your semester. Office hours are going to be, the TA's office hours are going to be completely remote. My office hours are going to be partially remote and partially in person, but they're never going to be recorded. And of course, everything is subject to change with the external events. And sorry, just I want to emphasize like all the stuff about like dropping the lowest grade and like late days and stuff that you'll see in the syllabus. There's like an additional exception with like COVID or sickness or religious holidays. So like that's like sort of if you're sick, then you'll get extra late days and extra whatever. And that's like working with student services. Any other questions here? Okay. Okay, so communication. This is in the written in slightly meaner language in the syllabus, but sort of the first thing for everyone is go to Ed Discussion and ask questions there. Make them publicly available. You can access the link through Canvas. Sort of in the syllabus, I say that we're not going to answer questions in like we're giving ourselves a 48 to 72 hour window to answer questions. That'll be slightly longer on the weekends. That's because there's almost 70 of you and 2 of us. But Ed Discussion is the first place to go for questions. Please come to office hours for any reason, course or non-course related stuff. And then use email as sparingly as possible. In particular, I'm going to straight up delete any technical questions emailed to me. And I'm going to also tell the TA to delete any technical questions emailed to us. Technical questions are only on Ed Discussion. Any questions about this policy?
What is the ED discussion?
Yes, great question. So the question is what is ED discussion? It is basically a like private message, like forum message board for the class, where you can post questions that the entire class can see, and then anyone else can answer questions. And then like the instructor can like endorse answers if we want to, like if there's good answers. You can see the link through Canvas. So for those of you who've officially enrolled in the course, you should have access to Canvas. And through Canvas on the left-hand side, you should see a link to Ed Discussion. And then you can, you don't have to go through Canvas anytime. Every time you can save that link. For those of you enrolled in the course, you should have also received an email from me this morning via Ed Discussion, which was linking to the course survey and like a doodle for office hours. Any other questions?
I think I saw that you said office hours start next week. In case we have questions about setting up Python right now.
Yeah, okay, so great question. So the question is office hours start next, so like we said, office hours start next week, but what if you have questions right now, for example, about setting up Python or just like about the course or so on? Great question. So I'm going to host an office hours this week as like a one-off time. It's not going to be the permanent time, but Wednesday at 4:30 this week outside in the cafe. I might send an email about this. I'm not sure, but so I will have 1 hour office hours this week. The TA's office hours will start next week, but like perhaps if like perhaps if there's enough demand for things like setting up Python and things like that, the TA might do an office hour this week. Just like say that you want that in the course survey, in the pre-course survey that I sent out. Any other questions?
Follow up. Do you also recommend using Python just in general?
Yes, okay. So the question was, do I recommend using Python in general or is Jupyter fine? So those are 2 different things. So Python is a programming language, which is like sort of like it's the language in which you're coding. Jupyter is a framework that like lets you run Python code, lets you run R code, Julia code, and a few other languages. So in this course, we're going to be using sort of the programming language is going to be Python. And then sort of we recommend that you do all the homeworks in what's called Google Colaboratory, which is effectively which is a fancier version of Jupyter Notebook. And like, for example, all the homeworks we're going to be giving you, like the assignment itself and the template in Python and Jupyter Notebooks or Google Colaboratory Notebooks. How am I dealing with people in the waitlist? Great question. So I am not directly doing that. So the wait list and like enrollment stuff is managed by student services, and student services sort of, they have an extremely busy time at the beginning of the semester. They do all the wait list stuff by hand. And so sort of the things that we've been told to recommend to students is wait a few days and see how the enrollment shakes out. Contact your program director about like which courses that you want access to that you like, maybe that you haven't had access to yet because there's a wait list. Contact student services, and then like please just wait a few days because they have an extremely busy start of the semester. But I have no direct control over enrollment or wait list. Any other questions? Yes, great question. So the question is the recordings will be posted. Will I also provide the PDF version of the lectures? The answer is yes, they should already be there. So one sec, was the links on the previous? Okay, so maybe course links are in one of the later slides, but there's a class website that's separate from Canvas. It's linked to on the syllabus. This lecture slides and next sort of Wednesday's lecture is already up. For the most part, I'm going to aim to have all the lectures PDFs online, like a few days before the beginning of the week at the latest. But yeah, everything's going to be posted. Yes.
Oh, are the quizzes going to be suggested reading?
Good question. I haven't figured that out. I think sort of I would say not on the suggested readings unless the suggested readings are also on the homework. So like the quizzes are really about like, are you paying attention in class and did you do the homework? That being said, we reserve the right to have the quizzes be easier if you did the suggested reading.
The homework of programming?
Great question. Yeah, so it's so the question was, is the homeworks all programming or is there like another part to it? So it's going to be about half or a little bit more than half programming. There's going to be what I'm calling conceptual component, which is like reading something and reacting to it, or like maybe doing like a very simple proof or like a math derivation or something. That's going to be maybe like 40% of each homework. For example, some of the guest lecturers want you to like Drumo, the first guest lecture, wants you to like having done some like pre-lecture exercise, and so I'll just tack that on to the conceptual part of the homework. Great question. So the question is, how do the readings fit into the lectures? I would say they're like supplementary. So they'll either go into like a deeper dive into something I spent like half a slide on, or they'll just provide like way more detail about something I spent like a few slides on, or they'll be like an application of something I spent time on. Any other questions?
Will there be like code demonstrations in class, or is that if there are, would be expected to post it too? It's just like take notes on it, right? Ourselves out.
Okay. Yeah. So the question is are there code demonstrations in class? And if so, do y'all have to participate in the class, like in the demonstration? No, I'm not going to ask anyone to like code live and lecture on video. I might do some coding demonstrations. I would say for the most part, don't expect that. Like sort of especially there might be a few times this semester where the TA will do like coding demonstrations in his office hours, but not like rarely live in class. Any other questions? Okay. Classroom norms, these are written down more explicitly in the syllabus, but sort of to summarize, like don't be a jerk, please be kind. There's a lot of people here with very different backgrounds. Some of you have like, have like an extra year at Cornell Tech than other people, and so you've taken a lot of the courses that other people haven't taken yet. Like just like please be respectful of sort of everyone's backgrounds and what they know, and like don't be surprised when like someone expresses something that they don't know, and like please kindly teach them. There's more explicit Zoom norms for like office hours, and yeah, for I guess we're not having live remote participation, so there's more explicit Zoom norms in the syllabus. Please read those before you go to Zoom office hours. Any questions? Okay, so the question was, is this class math heavy? The short answer is no. The medium answer is like, sort of, you'll see in the next, like in the lecture that I post on Tuesday, there's a little bit of math. In the lecture that I'll post, sort of, the lecture that I posted today for Wednesday, there's like, there's equations in the slides. And the lecture a week from today, there's going to be more math in the slides. That's to explain the concepts. Then in the homeworks, you're going to do in the homeworks, you're almost never going to do a proof. I would say there's an upper bound of like 2 proofs the entire semester, maybe an upper bound of like half a page of a proof the entire semester cumulative. So yeah, the short answer is no. Anything else? Oh, okay. Oops. Okay, so hopefully everyone knows how to access Canvas, a discussion, which is also through Canvas, Gradescope, which is also through Canvas. Gradescope is where you're going to be turning in all assignments. Gradescope makes it really easy for us, and that like you'll be asked to tag, for example, page 1 is about question 1, page 2 is about question 2, and so on. So please do that. Please do all the tagging when you submit assignments in. We might be slightly flexible for the first homework, but like we won't be after that. So that's where you turn in all assignments. There's also a course website. Oops. Yeah, so there's a course website. This is linked on the slides, which I guess you can't access unless you've been to the website. So there's a link to the course website on Canvas for those of you who are in Canvas. For those of you who are not, email me, and I can either maybe wait a little bit for the wait list to clear, or I can add you to Canvas right now. Yeah. Great question. Okay, I did not think of that. So the question is, do I expect you to sign up for a New York Times subscription? Because I think a few of the readings are to the New York Times, which might be behind a paywall. The answer is no. I will, great, okay, so let me make a note. I'll make a note of that where I will post any reading that is not freely available, I will post a PDF on Canvas. So please, so that is one of those things you can email me about. If like something is not available, I'll make it available. Like you should not have to purchase anything for this course. I mean, you'll need a laptop to code, or like a computer to code, but you should not have to purchase anything for this course.
Just on that, I think we get a free time membership.
Okay. Okay, so there's some discussion on whether Cornell gives everyone a Times membership. I don't know about that. But yeah, I'll make the PDF available. Okay, so I guess final announcements, like class, oh, wow, it's almost perfect timing. So my office hours this week will be on Wednesday at 4:30. They'll just be out, we don't have a room yet, they'll just be outside the cafe. You should have gotten an email for the course pre-survey. Please fill it out. It also has a preference form for office hours. I'll settle my office hours and the TA's office hours by the end of the week. So if you care to have your preferences taken into account, please fill it out. TA office hours will start probably next week, but if there's enough interest, maybe this week for like programming stuff. And then homework 1 will be posted by Friday. Okay, I know that is time up, so we'll take maybe all the other questions after I stop the recording and offline.